This example, 21 sample size, 55 years, that is the mean. Clearly I have to say it is the population mean. And the very last one, 6.8 years, it is the sigma. It is the population standard deviation. 21, that is a sample, n. So we got all the mu, population mean, sigma, population standard deviation, 21, the n, sample size. I told you, always we have three values: population mean, population standard deviation, and the sample size. Now, then let me ask you, what is the mean of sample mean? We knew it was same as the population mean, mu, which was 55. One more, standard deviation of the sample mean. Who was this? Sigma over square root of it. Sigma, population standard deviation was 6.8 over square root of 21. How much? 1.48. Additionally, we need a distribution. But yesterday, we had a theorem. Can you remember the name of the theorem? Simply, it was a CLT. CLT stands for Central Limit Theorem. So now I can say by CLT, now we have a normal distribution. Mean is 55, and the standard deviation is a 1.48. So now we have a normal distribution. What do we need? What was the question? The question was, find a probability. What? Less than 52.5. Less than 52.5. Less than, to the left. Okay, let me ask you now. Do you expect the probability will be less than 50% or bigger than 50%? At least we have to expect how much will be. Absolutely, we are going to take the probability from the z table, but from this picture, at least you can expect it will be less than 50% or bigger than 50%. Which one? Less than 50%. Why? Because the whole area was 100%, right? And normal distribution was symmetrical. Just cut half, that is a 50%. I mean the cut half, here is a cut half, like this. That is the blue one. The blue shade, that is a 50%. Absolutely, the red one, smaller than the blue one. Less than 50%. Good. So now, next, we need a z-score. You know, actually, the previous line was title, age, but now we need a standardized score. It's actually, it will be the standard normal distribution. Always in the middle, there is a 0. So we need a z-score at 52.5. Do you expect negative z-score or positive z-score? Negative, thank you. Here's a positive and here's a negative, right? So 52.5 minus 55 divided by the standard deviation for the sample mean was 1.48 divided by 1.48. So how much will be the z-score? So we subtract. Now the 55 is not the population mean. Now the 55 is the mean of the sample mean. 1.48 standard deviation of the sample mean, right? Yeah. So how much?
1.69.
Negative 1.69. Negative 1.69. Why don't you look for the probability from the z table? I don't have any z table. I'm sorry. Yeah. Why don't you Google? Yeah, using your smartphone, you can Google z table. At negative 1.6 and 9, what is your probability?
0.04, Papa.
0.04, 5 and 5. Should I do 1 minus? No, why not? Because we need the left end probability, and the z table gave us the left end. It is, right? Yeah, we don't have to. When we did 1 minus, when we need right end probability, right? But z table gives us left one. 1 minus left one will be the right one, right? But now it is the answer. So based on the average, 55 years old, what is the chance? Less than 52.5? Only 4.55%, right? So if I have some problem, for memory or something, I'm 48 years old, it's a big problem, right? Less than 52.5 years is only 4.55%, right? It's very rare. The young age is less than 52. But if I have the disease, yeah, it's a big problem. It's because of you, right? Yeah, you. I was kidding. I'm sorry. So it's not only take the answer, but you have to understand. You can interpret as what is the meaning of the probability. 4.55%, right? It is very rare for the younger people. Okay, yeah.